Hello everyone, so today we'll be studying about propellers straight from the manual of ATR. So what is a propeller in ATR? There are like six blades, propeller blades in ATR 72. So this is the reduction gearbox, it's a free power turbine, right? So we'll Google and see what is reduction gearbox and what is free power turbine. Reduction gearbox is usually for reducing or controlling the speed. Gearbox for aircraft. Alright. Propeller speed reduction unit. A propeller speed reduction unit is a gearbox or a belt and pulley device used to reduce the output revolutions per minute from the higher input from the power plant. This allows use of displacement internal combustion engines to aircraft propellers with an efficient speed range. So their job is to like you know conduct the aircraft propeller speed range, revolution RPM to an efficient speed, and free turbine. Now what is free turbine? This is gas turbine does not drive the compressor. Used to drive reduction gears for the propeller in a turboprop engine or the transmission and a rotor of a helicopter, also known as a power turbine or free turbine. An arrangement in which a turbine or stage of turbines in a gas turbine engine does not drive the compressor. Free turbine are used to drive the reduction gears for the propeller in a turboprop engine or a transmission and rotor of a helicopter, also known as a power turbine or free turbine. So I think it's okay. Free or power turbine pretty much sums up it, right? A free turbine is where the power is extracted from. A free turbine is a turbine turboshaft is a form of turboshaft or turboprop gas turbine engine where the power is extracted from the exhaust stream of gas stream by an independent turbine downstream of the gas turbine. The power turbine is mechanically connected to the gas turbine, hence the term free, referring to the independence of the power output shaft or spool. The power output shaft is called the spool. Okay. This is opposed to the power being extracted from the turbine compressor shaft via gearbox. The advantage of the free turbine is that the two turbines can operate at different speeds, and that these speeds can vary relative to each other. Okay, so they're to each other. This is pretty advantage for varying loads such as turboprop engines. Okay, cool. So the first bit is clear. Congratulations. The propeller installed. The propeller general description. Okay, now the propeller installed on the aircraft is a 6-blade Hamilton standard 568 Foxtrot or HS 568F, which means denotes the flange so F denotes flange mounted propeller system, 8 designates the propeller blade shank size. What is shank? So I have this blade shank size, right? So this is one shank, blade shank. Propeller, let's see. What is blade shank? Blade shank root is the section of the blade nearest the hub. Okay. Shank is the section of the blade nearest to the hub. Okay, so this one, this area nearest to the hub. This is the blade shank. Alright, from whatever I heard. Alright, so this is ThaiTechniques.com. It's a very good site. So this is the blade shank. Okay, I misunderstood. From here to here. The blade shank, the thick rounded portion of a propeller blade near the hub. So this one. From this side to this side to the butt of the blade. I suppose. Let me see another one. So yeah, this is the blade shank from butt to the deviation. Right. So from blade shank. Okay. The propeller. Okay, fine. So now blade shank is over. Designates the propeller blade shank size. So 8. That's what. Denotes the number of blades. 6 number of blades. Denotes a major model type. So S5, I think. No, model type is 5. And then Hamadel standard type HS. Hotel Sarah. Diameter 12.9 feet, 3.9 meter. So rotation clockwise, aft looking forward. So like, which means, let me tell you, aft looking forward, which means let me show you that. Okay, so this is what it basically means. It's not ATR, but this is what it basically means. Alright, aft looking forward, which is looking forward. So imagine it's got some blade in it, so it rotates this way. This is the way, clockwise. Alright, from aft looking forwards, that's what it means. Propeller is driven through rotation speed is 1200 rpm with 100% NP. Watt weight is 397 pounds, 180 kg. Okay, cool. Alright. Propeller driven through a reduction gearbox. Propeller driven through a reduction gearbox by the free or power turbine. It is driven through a reduction gearbox by the free. Okay, so this is what drives the propeller. Alright, and this is free power turbine, so through a reduction gearbox propeller, this rotates the propeller, and this is rotated by. Okay, so first this rotates, then this rotates. First the free or power turbine rotates, then the reduction gearbox rotates, then which rotates the propeller. So this is the source. Okay, the propeller is a variable pitch type, hydromechanically controlled, and which can be placed in reverse or feathering configurations. The propeller is a variable pitch type. What's a pitch? Okay, so let's start digging. What is a propeller pitch? What is a propeller pitch? The pitch is effectively a measure of how far the propeller would move forwards in one revolution. The pitch is used to control the speed of the air leaving the back of the propeller. The pitch of the propeller blade changes as you move along from one end to the other. Blade pitch often started to is the angle between propeller blade chord line and the plane of rotation of the propeller. Blade pitch is often described in terms of units of distance that the propeller would move forward in one rotation, assuming that there was no slippage. Fine pitch refers to a fine or low angle which yields to good low speed acceleration, takeoff and climb, whereas coarse refers to a coarser or higher pitch angle which yields optimum high speed performance and fuel economic cruise. Alright, which there were some variable pitch propeller. So this is what it is. A variable in an ATR, a variable pitch propeller. Right? So that's what it's written. Variable pitch type. Control and a variable pitch propeller is one in which the pilot is able to adjust the blade pitch angle. So pitch during the flight. The blade angle can thus be adjusted to its optimum value for the phase of flight, be it takeoff, climb, or cruise. In some installations, it is possible to feather the propeller. For a variable pitch propeller, the pilot controls the blade pitch with the propeller control. However, the propeller RPM will vary in the same fashion as a fixed pitch propeller as a function of engine RPM or of airspeed. A more sophisticated variant of variable pitch propeller is constant speed propeller, which, while in flight, will maintain the same RPM irrespective of the throttle lever movement or airspeed. Okay. Skybrary, another very good. Let's see the images. This is high pitch. This is low pitch. Okay. Okay, so this is a pitch angle, pitch or blade angle. Okay. So this is the like blade. So it may move this way, or this way. Pitch, higher geometric pitch. The root and lower pitch at the tip. Okay. So this, like in jet stream, it will always remain in yeah. Okay, so this is the feathered. Okay, this is the feathered mode. Fine pitch. Feathered movement. Coarse. This is fine. This is feathered. Alright, so this is feathered. So when it is like perpendicular, alright, this is this is feathered. Alright, so पातुलो भएको एकदम मसिनो खाली तेज धार वाला, that is feathered. फाइन भनेको चाहिँ प्यात्त पर्दै अगाडि आएर प्यात्त देखिने खाले यो पंखा जस्तो, राइट. just feather on your coil. So this is how. Just wait a second. I saw the photo. All right. Okay. So this is feathered. This is for fine. Okay. So like in jet stream, it's always fine. It's not. It's a constant speed propeller. So it's always in this mode. Whereas in ATR it's usually in fine mode when it's on rest also, right, when it's coming to land, so the landing will be easy and the drag will be less, right? Not landing, but alright, so this is what it means. Rookie wand. Okay, that's another good site. Alright, so hydromechanical control, so with all this fluid, SkyDrone and everything. So it's that, and which can be placed in reverse or feathering conditions, right? So got it. Feathering one go flat. Already very flat. I think no. Feathering one is it alright. The turbine that drives RGB can be described either as free turbine or power turbine. So proper general description still is there. Alright. The spinner, this is the spinner, the black one. So pitching the mechanism, the starting one, which results in pitch change. The hub, this is the hub, the below one. Alright, so these are blades, this is all transfer tube, and we got spinner attachment bulkhead, slip rings, propeller valve module with the propeller control adapter assembly. Alright, so this is how it works. First we get all from turbo machinery, then internal cavity, then feathering pump, and it goes to PVM, right? This is the HP pump. And it goes in here, the liquid for lubrication. For lubrication of gears and bearings of RGB, right? So the internal cavity, then it goes to overspeed governor, and the HP pump increases the pump. If we pull the throttle, if we push the throttle forward, HP pump increases pressure of the transfer of oil, and then it goes to PVM. Feathering pump, this for feather, and this is for HP pump. The propeller valve module is the main component of the blade angle and speed governing control. So propeller valve module, so this one, right? So the PVM, which receives mechanical and electrical inputs from flight deck and enables propeller pitch change operation. Receives mechanical and electrical inputs from flight deck and enables propeller pitch change operation, right? So same thing. An overspeed governor and HP pump and an auxiliary feathering pump are installed in the engine reduction gearbox. So overspeed governor, and then HP pump, overspeed governor, SP pump, and auxiliary feathering pump. So here is feathering pump are installed on engine reduction gearbox. Pump is here, SP pump is here, overspeed governor, right? Propeller governor as well. The overspeed governor protects the propeller from NP overspeed. Like if it goes over the limit speed, then that's what it protects, the overspeed governor. The propeller oil supply is composed of an internal oil cavity, this one, which always needs to be full, okay? An HP pump and a feathering pump. So HP pump and a feathering pump with integral valve and check valve. An overspeed governor. Alright? Overspeed governor. A propeller valve module. So PVM, here's the PVM, propeller valve module. Right? An oil transfer tube. So here's the oil transfer tube. You need it. A pitch change mechanism.